it started to spend 20 billion dirhams, which is about $6 billion into space exploration. And one of the best examples is the UAE Mars 4 mission. And hopefully by maybe the next 2 weeks, 2024, we need to have a lunar rover called, I believe, Rashid, if my memory is good. So the UAE is doing a lot of things, and they have recently chosen 2 new astronauts, and they're going to next week to the US for 1.5 years. Okay, so let me thank, first of all, Professor Minna Palmorth for accepting to be with us, and also Mr. Jacob for working out this program for us. We are very pleased to have the defendant embassy being part of this program. Professor Palmorth, let me say it is a surprise, she's a physicist. And that's very, very great, because we are all physicists, except the engineers. Okay, so sorry, Professor, I'm the best people in the world. Okay. So we try to be as brief as possible with us, because we have asked Professor Hamid to come and he did apologize because he has such a heavy schedule. That's why we asked Professor Ahmed al-Shamar to come and present something about the University of Sharjah. So please, Professor Ahmed al-Shamar, he's the Dean of Mechanical Engineering, is going to say a few words about the University of Sharjah. Please, Professor.
Thank you very much indeed, Professor Riaz. Very much appreciated. Thank you very much indeed. Thank you, colleagues. Really appreciate it. Good afternoon, everyone. Assalamu alaikum. I'm really delighted here on behalf of the university. And I really echo what says Prof. Riaz, the Chancellor, in the last minute. There's so many commitments, it can be in so many places at the same time. So I am here, being an engineer, but I'm proud to be a physicist as well. I'm proud to be a scientist, because I think multidisciplinary is the best element of everything we do here these days. I always see the engineer is always adaptable. The world is changing, we change in the world. But as one community, I think we're moving forward towards anything we do in the future. So just on behalf of the university, especially for our colleagues, so I'm delighted to have you here. Just to say a few words about the university, who we are and what we've been doing recently. So it's a young university established in 1997. When we started the university, we only had about 600 students and 30 faculty, i.e. academic staff. And now it's 17,000. Is the biggest university in the UAE. And I feel proud being Dean of College of Engineering is the biggest college as well, not just here, but as well as in the UAE. But as I told you, the university is moving forward towards the challenging, meeting the challenges of the world, and how we contribute into the community. So part of the university agenda, obviously, we have 3 themes. It's the academic teaching and learning, the research and innovation, and the community services. And as you can see here, obviously the University of Sharjah Space Program is part of the bigger, wider agenda of the university. So the university have 14 colleges. This is a part of the, obviously, called the strategy, the spirit related to the students, people, innovation, research, industry, and teaching and learning. So it's very well part of the spirit agenda that we have the 14 colleges. These are the pure academic. Then the research element, where we have a 3 research institutions. Is the one in charge in the science and engineering is called RISE, Research Institute, and there is one for art and humanities, and there is one for the medical and health sciences. And we have the SAASST, the Space Academy as well. These are one of the pillars, the niche, unique activities, because it's always, whatever you have, as you know, Professor Minna, in Helsinki, for example, or anywhere in the world, what this university is all about, what they do, what the niche, unique activity of the university. And what we see strongly, beside the research institution, we see SAASST here, the Space Academy, is one of the niche, unique, because not many universities in the UAE or in the region have such expertise and facilities. So we feel proud of that. To move on that, So you can see the journey of the university with the male and female. It's unusual. You see the female student is higher than, especially in the science and engineering discipline. You find around 50 to 60% female, which is unusual in comparison to the Western university. So we feel proud about that. But as you can see the trajectory, how the student number increasing by the year. But it's not just the number, it's the quality, to obviously feed them into the community where these students. So we have so many systems. We have the Arabic system, where the student coming from. We have the British system, we have the French system, we have the American system. So there are so many systems. We have to do a lot of equivalencies to meet the demand of those clients. This is really important chart to show you the different universities, and how we compete. I'm not sure it's not simply or any other universities. So these are the universities, if you like, the high-ranking university in the eyes of the Ministry of Education. So you find Khalifa University in Abu Dhabi, United Arab Emirates University, in Al Ain, University of Sharjah, the US, the American University, Zayed, Abu Dhabi. So these are, as a part of the benchmark, like any other university, we feel proud of what we do. And again, the credential, how in terms of the ranking around the world. So we feel proud where the university started here. To look at the 2014 and look at the trajectory here. And now I feel pleased and delighted and proud to be part of this institution. We are now number one in the UAE in terms of the research activities. And all this coming from the hard work of our faculty, the staff, all the researchers is here. Everybody have an input towards such achievement. But that reflected positively in terms of the world ranking, which is currently 441. So truly a statement the university put and a punching towards, obviously punching above its weight in terms of the national and international achievement. So you can see here the hard work is done by everybody. To sustain that, which is that where you're going to talking about sustainability in everything we do, how are we going to do it? What's the metric? What's the factors? What's the support? What's the investment? And hopefully we could move towards that element. So all in all, is a movement, is a young university, it's doing tremendously well nationally, internationally, and hopefully with the support of everybody here, we're trying to maintain and sustain such activities towards that. So I'll pass it back to Prof. Ilyas to tell you more focus about the space agenda here in the university. Thank you.
Thank you very much, Professor Ahmed, for the nice presentation about the University of Sharjah. The Sharjah Academy for us in the space science is part of the University of Sharjah. So, as Professor Ahmed said, there are 4 main research institutions within Sharjah University, and we are one of them, but we are mainly focused on space program. So let me present you our space program. So it's very nice, as you came, it's a very nice building. So usually we are visited by hundreds of students. As you can see, sometimes we have special programs and the parking is full. I believe 2 or 3 years ago, we had to organize an innovation week and the first floor was full. Thanks to that, it was not COVID time, otherwise everyone will be infected. So we are part of the University of Sharjah and also part of the Department of Biophysics and Astronomy, and Professor Abba is the chairman. So we are one family. So we do almost the same thing in terms of bringing this University of Sharjah to the top level in terms of research and also ranking. So if I take data, which is just for shortly for the Department of Biophysics and Astronomy, we are 6 astronomers, 70 students. We believe that's physics students. We believe it's an ordinary, and we have 90 students, 112. You see, because it is one of the largest physics departments in the MENA world, because nowhere and physics for sure as worldwide is not loved. People don't like to go physics, they like to go business, but not physics. But we have actual students. Well, because we have very nice programs in this. So we have, in terms of astronomy, we have 5 undergrad courses. We have 20 graduate courses because we have this new MSc in astronomy space science, and this is its 2nd year. So it's excellent. We have SAASST has 20 research assistants, we have 8 space science laboratories, and also 4 observatories. So we are purely space science institution. Usually when we see this, I thought, like a joke, I told them, like I said to Scott Kelly 1 hour ago, when you were planning, you saw sands and maybe you saw some tents. Have you heard that we are buildings? No, we do a lot of research. This center is an example of what we do. We do something that no one does it for us. No one does it for us. Because of the research labs, because of the material, because of the public outreach, because also the ranking university is so much. It's like we are #1 in public publication, really, and that's really important. Whether you get budget, you have to publish or perish, as you say sometimes. Okay, so in terms of the Sharjah Academy, let me go quickly. So we have the primary unit, we have the academic unit, and we have a research unit. Mr. Marwan is here, is responsible for primary unit. Professor Mashhoud is responsible for the academic, and myself, I'm responsible for the research. So in terms of criteria, we are largest in the main award. You can see 200 persons. It is very, very sophisticated. Hopefully, in the next 2 years, we're going to renovate it to be one of the best, not in the main award, but also in the world. In terms of the space science research lab, so we have several labs. We have a CubeSat lab, and hopefully by next June 2022, when we launch our first CubeSat, it's called Sharjah Sat-1. It will be an X-ray CubeSat to study the sun and also some X-ray, some X-ray stars. We have a radiosonde lab, we have space weather analysis lab, and of course, Minna is here, is responsible for it. So we are a family. We came from different countries, but we are from, because we do the same thing. We have a meteorite center, we have high energy astrophysics, very soon. We have a science lab, special artificial intelligence, and the Sharjah Optical Observatory, and also the Sharjah Regional Impact. So we are a complete space science center, and I believe all what any physics of the astronomy Palmorth is a regular. And for sure, we have also some other space vision. If I just go into details, this is part of what you need to know. As you know, in the sky worldwide is bombarded by meteors. And these meteors are very important because they represent a leftover of the solar system. How much we can collect one? And we call it meteorite. So we do that. So we have a system of 3 powers. One power is in Sharjah. This is in the US, so we have 70 cameras over the sky on sunset. So any of course the sky, in the sky we get the picture of it. So up to now we have observed more than 45,000 meteors. Okay, we're going to do better than that, but we do also on determination. This is part of the space weather lab. We have this tiny animals on, we have the GNSS station. What does it do? We send a signal to the upper ionosphere and we get the reflected back. We know how the solar wind, these highly charged particles, doing to the atmosphere. Because if you use your GPS, you may be off maybe by 5 or 6, maybe 20 meters. It's good for you if you're driving the car off by 20 meters, that's right. But how about if you send a missile to someone? Not to hit, not to miss. So we are doing not missile, but we are analyzing the upper ionosphere and so on. We have also this big highly integrated telescope. We observe solar radio bursts. Whenever the sun is acting, the sun also we receive some radio signals. So this system is responsible for it. We have also this, we're building this 40-meter radio telescope because illumination is a bigger, it's bigger. Each of these dishes is 5 meters. We have 3, so we're simulating a 40-meter dish, 40-meter interferometer, and we have 6 more. We have 1 kilometer radio interferometer that works at 1.30 hertz. And we have our own ground station. So on this Sharjah Sat-1 will be launched in June 2022. So many of the using our own ground. So everything is here. And not here, but outside the perimeter of this large building. We have also very nice Sharjah Optical Observatory, has 3 main telescopes. You may say, you need Sharjah, right? Yes, but this is also for teaching and bringing students to might know about astronomy. So we observe everything of the sunspot, of the reason, the calendar. So it is very nice system. You may have seen this nice building when you came. In terms of academics, so we have the MSc Astronomy Space Science, we have the MSc Space Operations start for 2022, but We had some problems with the MOE, with some education. We have this MLC references also work. So we have good programs, and I believe all programs we have about let's say 25 students. So it's good. This is all for MLC. In terms of international space cooperation, so we have several ones. We have with Germany, England, two universities. This is Cambridge, this is the French. This is the Italian, and also we are in collaboration with Istanbul Technical University for Sharjah. So we have some nice collaboration, and all of these they go years and years back. Just some SAASST facts, who we are. 8 established research laboratories. In each one, we have at least 3 research assistants, 4 observatories. So we have 2 optical ones, and we have 2 radio ones, 6 scientific instruments, worldwide class, 70 publications just for the academy. All of them is called Q1, Q2, and Q3. We do a lot of work. As we were talking before, we do a lot of work. The COVID era, it was limited, but we do a lot of work, a lot of workshops, a lot of lectures, a lot of open houses. We do so many things. This part of the public vision is also part of our science vision. We have 20 beautiful research assistants. That's fine if I say beautiful, not accept beautiful research assistants. They do an excellent work. Because this is where how we can get our budget. You show what you are doing in terms of research paper. This is really important. By the way, by this month, we have this IPC meeting, and this academy is presenting 2 papers. And we presented 19, we get 12 accepted. This good. We don't ask the board, but we got 12 papers accepted. And because my research also work very hard. We have SAASST, we need to show what we do. And also more than 70, thank you, Professor, so 70 now is 112, and more than 100 internship. We open our doors summertime for the student, because at the end of each, program of each student, they have to do the internship. And because of the past 2 years, so most people don't find anything because of COVID, so we did open our door every summer. We accept 25 students from all over the UAE, from University of Sharjah, from Khalifa University, from the AUS, so from everywhere. And I believe this is a good role that we have. This Dr. Antonos, I talked about high energy also physics in the physics system. Okay. Thank you very much. Please, Professor, it is your turn now. I have to sit.
Yes. Thank you very much, Professor Ilyas, and thank you, Assalamu alaikum for everybody now. Thank you very much for inviting me here. I'm very proud and honored to be here today, and I'm also have to say I'm extremely impressed, not only by this country. It seems that you are basically the only ones who are actually doing or having a great vision for technology development in the Middle Eastern countries. It's very excellent work that you are doing. You are actually thinking about the future. This is very important. And also, I mean, this place is really huge. I mean, and very beautiful buildings and everything. I'm very impressed. Thank you so much that I can be here today. Okay, so my name is Minna Palmorth. I'm a professor in University of Helsinki and at the Finnish Meteorological Institute. So I'm a joint professor and also director for the Finnish Center of Excellence in Research Sustainable Space. Let's see if it works now. Yes, it works. Okay, so Professor Ilyas asked me to talk about sustainable use of space, and then there's a little bit of my own work about predicting space environment by modeling. So I'm a modeler. Then there's one also maybe of interest to you. I'm also doing citizen science in Finland, so I'm giving you an example of what we were doing in aurora research. I know you guys don't see a lot of aurora here, except if it's really big, then probably yes. But if you come to Finland, especially in Lapland, there are aurora in the sky. Okay, so As you know, space is actually a mega trend nowadays. And here in this view graph, you can see all of the spacecraft which have been launched into space from 57, from Sputnik 1, was the first spacecraft. You can see that the Cold War was like a huge number of spacecraft, about 150 spacecraft sent to space every year. But nowadays, look at the increase during the last couple of years. And this, of course, is allowed by the access of space has changed. In former times, only the national or not very big nations or big organizations were able to send a spacecraft into space. But now access to space has changed, and that has meant that now there's a lot of spacecraft being put to space, and most of them are economically driven. And of course, the applications which are behind here, economically driven spacecraft are, communication, navigation, remote station. We just came from the Russian Space Center, and they are also doing this as you are too. So what this means, of course, this era is being called new space, you guys know. And space economy is actually very much increasing also. So there are several investment banks which say that the space economy, which is now calculated around $300 or 60 billion right now, will increase or maybe triple in the next couple of decades. And what this means, of course, the consequences for this is, of course, that you are nowadays having lots of space objects. So space is being littered right now with new spacecraft. And this animation is a bit.
You can click on.
No, doesn't work. So anyway, so there's a lot of spacecraft right now, and space debris in the space. And this is a total number of space debris in space right now. So here is the year, and this is the total number of objects. The black curve is total number of objects. Then it can be divided in different categories. But if you look at the total number of objects, it's increasing very steadily. You can see a couple of jumps in the total number of debris. One of them was Chinese anti-satellite test when they shoot down their own or hit their own spacecraft in 750 kilometer orbit, resulting in a massive increase of space debris objects. And also the collision, there was a collision, unintentional collision between two spacecraft, also a number of objects increased very rapidly. And in space, both the big objects and small objects are a problem if they are debris. Here's one of the largest debris problems, and this is an Envisat spacecraft from the European Space Agency. It's about a bus-sized vehicle, but it's a zombie. So they were doing some science operations until the very end, and then they just lost contact to this spacecraft. And it's in a very important orbit. So these orbits are like motorways in some way, because people are very much using the same orbits all the time. And Envisat is in 750 kilometer LEO orbit, going in north and south circular Earth. And if Envisat hits anything, because it's a zombie, you cannot maneuver it, you never put anything on this orbit again. It will be closed for operations. And that's a problem for many spacecraft. However, also the small objects are a problem. Here's a picture of the International Space Station window. It has been hit by a faint particle, a gram weighing a gram. You guys are physicists, you know what momentum is. A gram weighing, faint particle weighing a gram moves moving 7 kilometers per second, as they do in space, gives the same momentum as a fist-sized rock hitting your car windshield on a motorway. So also the small particles are a problem for spacecraft. And ISS is constantly doing maneuvering so that they can be finding an orbit where it's more safe for the astronauts. Would not be nice to have a big particle hitting your spacesuit when you are doing spacewalk. Debris scenarios. So here's a paper from a game theoretical paper. It's a mathematical journal doing game theory. Here's a year and number of debris. If we don't do anything, the red curve is what is predicted, and the factor behind here is so-called Kessler syndrome. So the debris objects will start colliding with each other, and there will be lots of small debris then resulting in this collision. So you will get decreasing size of the objects, but increasing number of the objects. And here's just a game theory, like if US and EU takes 2 of their own spacecraft, which are the most problematic for themselves, if they take them down every 2 years, then we are in this situation. So deorbiting or deallocating your, basically what is behind here is that the space should be thought about as an asset. It's an asset to have. You have an orbit, and you should take care of this orbit, because otherwise everybody is using their assets very non-sustainably, then we will be in this red curve. And in space there are 2 types of debris, like the debris which is already there, and the debris which is coming from the new launches of the new spacecraft which are being put there. And a small center of excellence in a small country in Finland cannot do anything about the existing debris. That's a very difficult, extremely challenge. Maybe you guys could take up this challenge to clean up the existing debris. What we can do is to make sure that there is no more new debris. So if we build our spacecraft sustainably and responsibly, then we can prevent the future debris. And that's exactly what's in the heart of our center of excellence. So if you are thinking about preventing new debris, there are 2 very important factors behind here. One is radiation tolerance, and the other is deorbiting. So radiation is the one which is making your spacecraft degrade sooner rather than later. And deorbiting means that you just take your spacecraft down after you've done your mission. And then that hopefully leads to sustainable use of space, longer lifetime for the spacecraft, safer orbits. And that is exactly what our Center of Excellence is doing. So we are studying the environment in order to understand how to build durable spacecraft. Then we also develop cost-efficient deorbiting technologies, and the aim is to make a significant improvement in the orbital safety. And here's our program. So Finland has been in space business already from way back. Our first instruments were provided in 1980s, the international spacecraft. We have been basically providing instruments on international spacecraft made in European Space Agency, Russia, NASA, so on. But then from 2017 onwards, we put our own first spacecraft up, called Aalto 1, and then the people who were educated in the Aalto 1 program are now actually owners of the company. So they established a company which is actually rather famous nowadays, a company called ICEYE, it has a niche area in SAR technology, and they are now one of the market leaders in SAR technologies. They are making the smallest SAR radars in the world. However, our program in the Center of Excellence is to build and launch 3 CubeSats, and each of them has a science goal and then a technological demonstration. The science here in blue. The first one, Crucial one, we are launching quite soon next year, and it will. I mean, if you guys know about the radiation belts, if you take any given place in the radiation belts, the amount of radiation there is made up on how much radiation came there and how much was lost from that place. And the first spacecraft is looking at the losses of the radiation and also demonstrating this deorbiting technology with our center. Then second, Corsair 2 is a GPO CubeSat. It will go into the heart of the radiation belts. There are no CubeSats currently which are flying in the GPO. And there we are looking at the magnetospheric acceleration processes, so wave particle interactions which give energy for the particles, and then radiation tolerance is the technological demonstration. And then the third spacecraft, INSALA, as you guys say, flying to the solar. Anyway, enduring in space, as I said, is very much dependent on something called space weather, which Professor Elias was also saying, talking about. And of course, everything in space weather is made up by the sun. And in Finland, we can see the beautiful aurora, which are caused by the magnetospheric electrons within the atmospheric atoms, and then they excite the atmospheric atoms and release the auroral light. So this is the visible side of the space weather. And here's the satellite radiation environment. So these are now the SAMPEX satellite measurements of killer electrons. So electrons which are very much accelerated, so they are relativistic. And you can see how hugely dynamic the radiation environment is. And why this is a problem is that our critically important societal functions are actually dependent on radiation belts. So whether satellites go they are in the geostationary orbit, and then habitation satellites are also traversing the radiation belts. There are 3 kinds of things that can happen in the radiation belts. Single event upsets, with a particle goes to a bad place in the spacecraft, that can be a problem. Aging due to the continuous radiation dose, and then also spacecraft charging. And here's a picture of a European Space Agency satellite solar panel, which has been charged. So as you know, the solar panels are sometimes charged differently. So one panel has one charge and the other panel has some other charge, and then there's a lightning strike basically in between them, which can cause a lot of problems for the solar panels. So spacecraft charging both in the outside of the spacecraft and also in the inside of the spacecraft, internal charging are problems for space. The space weather, as you know, are the conditions in the near space which can affect harm. So we are actually doing something which is negative. We are trying to understand negative. Here's a picture which I actually made my master thesis on this in 99. So here you guys are in low latitudes, are also, as you said, ionosphere businesses important here and signal propagation to the ionosphere. Here are low latitude ionosphere plasma bubbles. I would like to actually, if somebody is doing this, would be nice to understand what's being done lately, because I made my master thesis about this in the 99. And so this is now lighter material, this lighter material, tensile material. So if the lighter material is upwelling, lifting up in the ionosphere, if you have a spacecraft signal which goes through this bubble, it's lost. And as far as I understand, I was told, I would like to know if it's true, as the oil drills are controlled by the GPS signals. And if the GPS satellite sends a signal through a bubble, that stops the drilling because you don't know where the drill is. So that's a huge problem, I guess, for the low latitude countries. But if you know this more about that, I think you know what's there. But anyway, future space weather forecasts are based on what, as you know, weather predictions are based on weather models. Space weather predictions are based on space weather models. However, the problem is that the weather people they have these spaces because they only have hydrodynamic forces. They don't have electrodynamic forces, electromagnetic forces at all. They have a very small planet here where they can look at the weather in space weather. We have solar wind coming. Our planet is there, and the volume of the simulation is huge, million by million kilometers easy. So to make a simulation for this sort of a system, the other thing that you have to think about in making a simulation is what is your physics in the simulation? What kind of equations are you solving in the simulation? And in magnetosphere, you can take basically three types of approximations from the plasma kinetic theory, which is the fundamental theory controlling the plasma motion in electromagnetic fields. One is fluid theory, so magnetohydrodynamics, you assume that the plasma is fluid. Ion physics is relevant in 10 to 100 kilometer scales, and then electron physics even smaller scales. So another approximation is that you take into account ions but neglect electrons, and then the fluid kinetic simulation is where you take into account also electrons. So these three types: fluid approximation or MHD, hybrid approximation where you take the ion physics but neglect electrons, or then fluid kinetic. And actually, the most used tools, modeling tools for space weather have been in MHD simulation. So you assume that the plasma is one fluid and it has only one temperature. Basically similar to hydrodynamics, where if I take a volume here and take the number of particles and their velocities in this volume, I can put them into a Gaussian curve, and the temperature is the center of the Gaussian 23 degrees here. But in space, if you do the same thing, that actually fails, because in space you have several populations of plasma in the same position. So you can have the Maxwellian kind of population here, and here's kind of Maxwellian ion temperature in spacecraft observations, and then you have another population. You can have several populations in the same place. So high energy particles, low energy particles, so on in the same place. If you assume that you have a Maxwellian population and take the one temperature, your simulation is fluid-based, so it's magnetohydrodynamics what you are doing, and it's rather okay in the average case. So you can take, you know where the bound shock is, you guys probably, so this is the solar wind coming, and our planet is the obstacle to the solar wind, so it creates the bow wave in front of the planet and the magnetic field. So position of the bow shock is okay, position of the magnetoforce, the outer boundary of our magnetic domain is okay, but then especially in the geostationary orbit. In the geostationary orbit, which is critically important for our society. You have cold population, warm population, and hot population from the radiation. So MHD fails in the inner magnetosphere. And here are the different global modeling approaches. MHD here. These two are hybrid. So basically, MHD nowadays assumes that ions and electrons are the same fluid. It's very quick runs nowadays basically a real time, 2 weeks. When I started my PhD in the beginning of 2000, I was making MHD simulation on my desktop computer. They took 3 months. Computer resources have increased, so now they can do it in real time. And the fluid scale and the resulting physics is in fluid scale. Nowadays they can cover the entire solar system with MHD. However, if you see, here's the bouncet now. Here's the solar wind, here's our planet. So this is the shock which forms in front of our planet. You can see that it's really dull looking, very average. These two are hybrid simulations. So this is something called big particle itself simulation, where you assume that the ions are particles and electrons are fluid. This is better in computationally, takes a little bit longer than the MHD. And then the third here is our glaciator. Now, the difference between distribution functions and particles is that in big simulations, you launch particles to the simulation, and then you follow all the particles, and each phase you construct the phase space, the particle distribution from the particles. And that is, of course, a function of how many particles you have. So the less number of particles, the worse is your distribution function. So if you think about here, here's the distribution function, which gives you the plasma temperature. So if you have not so many particles, you don't get a very good distribution function. So you would have to be launching lots of particles in order to get an accurate representation of the distribution function. And that's why the big simulations are very noisy. You don't really, you do see some kinetic features here, but you don't really see how they are really. In Glaciator, we don't launch particles, but we solve the distribution functions. And that's why this is so accurate. So this is gives you the perfect representation of ion scale physics in space. And what we actually do is that we first divide the 3D space, XYZ space, in grid cells, and within each grid cells we have this particle distribution function, which we solve by the Lazo equation, hence the name Glaciator. And this is fully self-consistent, so go back and forth with the real space and those. So challenges in making a space weather simulation, a global scale space weather simulation, which has both the solar wind and the magnetosphere and the ionosphere, that's called a global simulation. The challenge is that you have a huge volume, million by million kilometers. You have a very dense grid, ion scale grid, so you have to put this huge box, fill it up with basically 200 to 300 kilometer grid size, so you get a good resolution. And then within each of your grid cells in space, you have the velocity space, which is also 3-dimensional. So you actually have 6-dimensional grid and 5 to 10 million real space cells, meaning 10 to the power of 12 total number of space cells over 10 to the 5 times this. And if you add up this, you get a beta clock. So you have to have a supercomputer to make this possible. Otherwise, it's not possible. Beta, if I were made to my simulations on my laptop, that would take 3,000 years. So now I put my simulation running, and in 3,000 years, when you guys have all the inhabited Mars, my simulation is great. Anyway, this is one of the pictures that I'm most proud of in Glaciator. So this is a scaling figure. So thousands of cores in a supercomputer, and here's the number of cells which can be calculated. Most codes are such that if you increase the number of cores, your scalability goes down because your code cannot take into account all of the computing power. But we have almost a linear scaling, meaning that when we put more number of cores, we get either larger simulation boxes or faster simulations. And here's our relative performance of Glaciator from where we start, like normalized now, where we started in 2008. So then we were doing a power of 0 computations years of time. If we were only using the largest supercomputers in the world, so this is the top 500 supercomputer further. If we were only using those and not doing anything in the algorithm side, we would be now doing around 3 orders of magnitude larger simulations than we were doing in 2008. So not a very good progress. But since we are also doing algorithm improvements in our simulation, we are now actually beating the top 500 curve, and now we can do high resolution 3D or 6D. So our simulation is actually the most accurate in the world. And it's been developed with this strategy that we don't try to get the background music.
No problem.
Oh, okay. Anyway, so animation scroll again. So the strategy here is that we don't target to the present resources, because as you know, supercomputing resources are flowing all the time. So if any given software the development of that takes around 5 years. So if we were targeting to the resources that we have now, in 5 years, when the software is ready, it would already be old because it would be using past resources. So what we do, that's what you do in football also. You don't pass your ball to the guy where he is now, but you pass it onward so that he can catch it up. So the same one here in Glaciator. Let's see if I get the next. Oh no, now it's going really badly. Doesn't move forward or
Sorry.
backward. Can I go? Yes, yeah. Yes. Now we are running at scale, utilizing, hopefully next year, we're actually piloting. Finland is putting, I believe it's the 5th largest supercomputer in the world. It will be running in Kajani in an old paper mill factory. And basically the carbon footprint of this host is actually negative because you can use the heating power for the computer to keep the village of Kajani with those heating. So we are piloting this very large system this year, and that enables us to understand the space weather in context in higher scale. Okay, then I go to the cities and science business, which Professor Elias also asked me to talk about. So here you can see the nice aurora, which you can see from Finland. Here you can see a curious feature. And this big video is by Karisaari. And you can see these blue stripes in the aurora, the diffuse gray aurora. And actually so Finnish, there's a Facebook group for aurora enthusiasts in Finland containing about 20,000 people. And once they contacted me several years ago and said that, can you, dear professor, explain the physics of aurora to us? So I joined the group and started to explain it. People new people came to the group, and I noticed that I have to always explain the same things again about how the aura, how they are born and what one of those things. So I decided to write a book. Unfortunately, it's in Finnish only because the publisher doesn't think it's people are interested in aura, so they are. Anyway, so I wrote a book which basically is like a bird watching book, but instead of birds, you take the auroral forms. And I also have a red star classification for rarity for the auroral forms. So, like, what kind of aurora can you see, and what do they mean in practice? What can they tell about the space beyond? And then I made this figure together with the citizens in the group. And then one of them, Matti Helin, when I was categorizing these different auroral forms to the book, Matti asked me, what are these stripes? And I was like, well, I don't know, I haven't seen them, but let's not put them into the book because otherwise the publisher gets mad at me. I haven't made them. So we left the stripes out of the book, and here's his folder, by the way, and then the book was published. I was sitting on my couch and messaging with the citizens, and we were like thinking, yes, great publication party, and everything went well, and very nice thing. And then Matti Helin, this is actually from that night, Matti Helin said that the stripes are on the sky. And then I said that, let's go. No, you have to go and take your camera. So because we were like connected to mobile phones all over Finland, those people took their cameras, jumped and went taking pictures, and I sit on my couch and messaged them, no, take pictures, and we were actually making an ad hoc measurement campaign on this night of October 7, 2018 to produce pictures. This is one of the pictures taken from Laitila. Then this is one of the citizens, Pirjo Koski, was saying, don't they look like dunes on the sandy beach, so these stripes here. So then we started to talk about them as the dunes, auroral dunes. And I have a very brilliant postdoctoral researcher, Maxime Grandin, who developed a triangulation method. So here's one place in Finland, here's another place in Finland, and both of them got a picture of the dunes at exactly the same time. So what Maxime then did was that he used this Stellarium open source planetarium software, identified the star behind the dune feature in Laitila picture, and then he identified another star behind the dune feature in the other simultaneous picture. This then gives the geometry for the altitude of the dunes. And we got the altitude mapping back to 100 kilometers. We mapped those in ground and gave the wavelength of 45 kilometers. So here are the map dunes now. There's our country, Finland, there's Sweden. So actually those dunes were about Sweden. There's Laitila, there's Kuopio. Probably you guys know this GPS satellite tomography business, where you send a signal from GPS and then you measure how many electrons are on the back of the signal. So here's the original data, and as you can see, it's not really accurate. Like the resolution isn't good enough to show whether the stripes are already in the precipitation or the stripes done by something else. However, what we interpreted in the end is that there are gravity waves going towards the upper altitudes, and sometimes these gravity waves are sandwiched between something called mesopause, and then there's an inversion layer, which is like sporadically comes once in a while. So here's the temperature, so mesopause is the lowest temperature, but then there can be an inversion layer, which makes a wave guide. So the gravity waves go upwards, and then they are sandwiched in this region. Then if you think about like aurora precipitation comes from above, and then you have a wave in the atmospheric density. Means that at some place you have lots of excitation targets. Adjacently, you don't have so many excitation targets, atomic oxygen, because there's this wave. So if electron comes at the place where there's lots of oxygen, will give lots of excitation. Electrons come to an adjacent place where there is not so much oxygen, so not so much excitation. So therefore, you can see this variation in the excitation light. So that's how we explain this. And we also, so we think that these aurora are actually a manifestation of something called mesospheric bore, a density oscillation in the atmosphere. Why it's important is because this region is very unknown. Sometimes it's called ignorosphere. You can't fly here. Your spacecraft doesn't. I mean, it will burn there because this is the place where spacecraft start to burn when they come down. Your radars go to this height, maybe, so not high enough. Rockets could go through it, but then there will be only one measurement per time. You could sound them with ionosondes, probably, but then you would have to have the ionosonde exactly at right position. So these auroral pictures, which are taken by citizens, are actually very important in understanding this very unknown layer, last frontier of unknown unknown regions at the Earth. Okay, that was it. Thank you very much for giving me this opportunity, and I hope this was understandable and interesting for you guys. Thanks very much.
Do you have any questions, please?
Yes, please. So thank you for trusting. Please just go back to the slide. What do you mean by gravitational wave?
Yeah, so gravity waves are, so for instance, you can have like orographic waves. So you have a mountain range, and then your air goes like upwards because it cannot, I mean, the mountain is an obstacle for the air. And then that gives a disturbance for the air. So when this gravity wave goes toward higher altitudes, you have an oscillation in the density of the air. You have all kinds of gravity waves in the atmosphere. So there are also gravity waves, even from many sources. Orographic waves are only one source. So one of the things here is that why are these waves so regular? I mean, if they would be just normal gravity waves, you wouldn't have this monochromatic waveform here. So you really have to have something which is making those waves monochromatic, and that suggests that there is this wave light going on in the atmosphere or between the atmosphere and space.
Thank you.
Any question? Just a comment, Professor Minna. You talked about space weather modeling. So are you taking into account the solar modeling? So the atmosphere have a model like space weather predicting the model?
Yeah. So they are taken into account by giving, let's say, a picture in here. So that's taking care of the initial condition given at the solar boundary. So we take the solar wind parameters and give them to the model. So the distribution functions here are approximately Maxwellian or Gaussian. And that's a good approximation because in solar wind, that's normally what you have in plasmas. But then, and then we just leave the computer do its magic and it gives this kind of.
Because what we are doing with some people transactness, we're looking out the white paper for space weather spacecraft.
Yeah,
So to be
yeah, the
able
L5.
to have you on board if you like, so we can.
Yeah. Why not?
Yeah,
Yeah, that
a
sounds.
50-kilogram spacecraft.
Oh, yeah, is this the L1, L5 spacecraft? Yeah, the one which is being launched by the European Space Agency. Okay, yeah. So I know some of that spacecraft, but I haven't been involved in the space requirements for that. So this is mostly basically here is like about 20 Earth radii upwind. So it's about so the L5 spacecraft is so far away solar wind that but you're correct. So if we could understand what parameters of the solar wind are already at L5, you could feed these models parameters that are coming to the sector which hits the Earth.
Okay, I will put you on the book for communications.
Okay, thank you.
Yes.
Is there any sound features for these patterns? I mean, do you hear anything?
Yeah, yes. So there are, for instance, these famous Whistler waves, which you can hear, and space is full of waves. You have lots of different waveforms. I mean, in plasma physics, there are, you guys know, lots of waves. You can basically transform those waves into sound. That's right.
Actually, the people can hear some.
Yeah, and that's actually, we had a paper, doesn't show in this figure, but there are these special waves which are called ultra low frequency waves. And we had a paper about how they transmit from the solar to the mesosphere. And for PR purposes, we actually did that. And that's in YouTube, those sounds. So you can actually go to YouTube and listen to those waves if you're interested. I can put up the address for you.
What about the aurora?
Aurora, you mean the gravity waves. I haven't heard that those would have been listened.
Okay.
I haven't heard.
Thank you
Can
very
I
much.
add just into this discussion at the fair, with the predetermined on such a pattern of thoughts that would have influenced somehow or kind of a prediction of the weather. So instead of going upwards, I would like to look at downwards.
So the basically the connection between space and atmosphere, there are several mechanisms which are we are, or space is considered as a boundary condition for the upper atmosphere. I have one project which is looking at basically electron precipitation from the outer magnetosphere, and those electrons, when they precipitate into the polar regions, they sometimes cause ozone loss. So obviously, polar regions where if you don't have ozone, the UV goes straight through, and that has climate implications in the polar regions. And that's one of my projects in this space-atmosphere interaction. But in this Dune aurora, so they are like this is very new field. So maybe I can go here again if I have the literature it's actually here hidden underneath the Zoom. So if you can put, yes. So here's the paper. This is the first paper which was published from the Dune aurora. So this is like a very new area of research, and the first paper is this one. We don't know what about the dunes yet. So, but what I actually think, this is my, which I wrote also in the discussion of this paper, is that it might be that space weather is actually modifying the conditions when this waveguide is there. And if it would be so, then it would be a totally new topic. It would be a new boundary condition for the atmosphere. So it's very interesting. And the problem is that I don't have a project for this right now. So in Finland, everything is done in projects. So you get a competitive project from the academic Finland or European Union or something, and then you do your research. Here I didn't have a project, so I had to do it on my own time. So now let's see what happens.
So what's fascinating is the waveguide we're talking about. And inside the waveguide, waves, different things, some of them speed of light, and some of them distance, like a move velocity, okay, and then phase velocity. So I can see that from here where there's interchange. So the interesting subject. But the other question may be, and this will bring the audience benefit from the whole talk regarding the sustainability use of space. As you know very well, currently it's not being governed.
Yes.
Okay, it's chaos.
Yes.
Everybody wanted to have a piece of that. And you talked about 1,000 and maybe by year 2,160, 90,000 debris and spaces. So the subject is when.
Yeah.
Will the United Nations have a power? Will the big boys have a power? Who's going to govern the space? Otherwise, we have a lot less in the air. We're going to have a lot less in the space.
Absolutely fantastic question. Thank you for this question. We actually went to UA Space Agency and discussed about this space regulation business. And what I really find very important here in UAE is that you also have a similar way of thinking about the sustainability of space as we do in Finland. So we are very much more like international rule-based system where we internationally negotiate and agree how we use space. And it's very important there are many players in the negotiation board, because if there would only be the big players, the US and China and Russia, they would like agree amongst themselves, and then the others would have to comply with their agreement. So it's important that we are in the United Nations and try to make up a mutual agreement how to utilize the space. Because if we don't do anything in the future, it is possible that the future generations do not get to use GPS navigation. Or, you think about the future self-driving cars, which are based on GPS navigation. I want to know what is controlling the signal and where does it come from. The signal cannot be trusted. Or if you even get a signal from space, that will be a problem for future. So, if this isn't agreed, isn't negotiated how we do this in the future, it might be that the future generations don't have space assets. We go back to Stone Age. Yeah.
Okay, this is part of our second part, the use of sustainable space. So please, Professor Minna, Professor Ahmed, Professor Mashur, please.
You're in the hot seat. You're in the hot seat too. This is your subject. I'll sit in the corridor. I am engineer. This is the business.
So let me address a couple of points. I want to do your last statement space, and you mentioned the top-down So what do you mean by that?
Yeah, so now, if you think about international regulations, for instance, how to regulate the climate change. Is it easy? No, it's really difficult. And now, how they are doing the climate change negotiations now is like top down. So they have this international like arena where the country says that we want to do this and that, and then they try to find a compromise. That's top down. The bottom up is that if there's a, for instance, company like which says that okay, I think that my that space is an asset for whether spacecraft or something, and they want to keep their spacecraft vicinity clean. So I'll make up a company and clean the space for them. So that's a bottom-up approach. So somebody invents something, a new technology, how you can improve the situation. And if we do both of them, top-down process, the negotiations between the governments and then new startups, new businesses, new innovations, research, development, then you can maybe at some point get a.
I would like to ask several points, several points additional to that. If I understand it, Professor Sure, as you know, so a lot of countries have heard about lunar exploration, lunar habitat, and so on. In your there is very expensive. So how can you sustain such a lunar base without requiring any supply content and so on? Very important.
Yeah, it's actually the future of the space exploration, as we all know now that more than a country now is interested in going to the, including UAE. What to do there? How to get there, and what benefits we can get from going to the moon, as we know now, 3 years of program to the moon. Now, Apollo in the last mission, Apollo 17 was in December 1972. But about years of not going to the moon again, which was and how can we actually build a sustainable, say, laboratories, I would say, not laboratories. We start with a small laboratory. How can we manage it? The first thing, I think, helium would be the key for such exploration. Sorry, the hydrogen. The hydrogen is the fuel for the station that are going to be built there. Since it's easy to extract hydrogen on the surface of the moon, so we have to focus on this part, the source of the energy, and also we also need to focus on not to pollute the moon. We already did on the air, as Professor Ahmed said. We polluted the ground and the space, and so we have to keep eye on the moon in this aspect. So sustainable for me is our goal, and the most important mission.
I think Professor Ahmed, you have talked about having a special heat sand going in active spots. So that maybe 6 you heat sand over there, and that have this coming from using that special
I think so. I think it just to, if you look at the big picture, what we hear from, we got a lot of elements. We've got technology, we've got sustainability, we've got material. What we see, it's kind of initially the golden from the top countries in the world. However, sending so many species, so many things, they are moving. So that's the path. Coming back to the lunar exploration and so on and so forth on Mars, everyone going to Mars, that's obviously reflecting about the ancient technology, knowledge, understanding. So kind of new technology from material point of view, from data analysis, big data, seeing the artificial intelligence, deep learning. So do we need, so we sending, for example, instead of every country sending, for example, designing, can everybody work together, as we mentioned, for the benefit of our space, in terms of all the different, what we're talking about, all issues. If we, contribute as one nation, one country, and one movement, and then the data we could pick up from that, everybody, and then since there is no regulation, and nobody policing this way, that way, I genuinely believe that we are moving much faster, because such technology needs funding. Some countries have a good fund, some countries may have the knowledge, the expertise, not necessarily. But bringing all this together, all this together, I think we simply move it faster. But from technology point of view, materials do play massively. Longevity of materials, like what we see currently with the stations, there is a certain time, certain pattern for them to last. But can we the new composite material? Can we get some, especially the graphene discovery? Can we have a discovery that the material could last a lot longer in the space rather than every certain period of time rebuilding and rebuilding and rebuilding rather than sharing? So I think there will be minds, different minds, but we need a champion. We need to control what's happening here. If we live in that, the new generation, hopefully, we will be doing. We could pass in the back to them. Knowledge, they are the makers, and we mentioned about the GPS, which is the simple thing current, no mobile phone. And imagine the new generation don't have access to certain access knowledge, the back to where one to the old. So I think the message is technology is there, everyone pushing for it, but we need to work together as one nation, one world, one country. That's the way forward.
Prof. Minna, here the account has this long space points. We have units, so we have this space law years ago. But you remember what happened in 2009 when the Russian satellite collided with satellites. What's now? What's the approach now? We have so many space policies. We have space policies because space, I believe, belongs to us. How can we ensure that such kind of thing that will not happen?
Yeah, but that's a very important and exciting question, because I don't know anybody does not somebody know an answer to that.
We don't have
So,
to
yeah,
do the US space force.
yeah. So here are, a couple of layers here. Is that first of all, if we don't have a binding international regulation, so only thing we have internationally is like it's like they call soft law in the people in the law who are law experts call it soft law. It's not binding. It's kind of only putting the flight lines. Please take your spacecraft down after 25 years or more, and so on. Then the only ones who actually can really regulate, are the nations. And we went to UAE Space Agency, and they showed us the slides of your space legislation, and it could have been exactly our space legislation. So our legislation is similar in that it recognizes and so on. And but different countries have different levels. So some countries just, because before you put the spacecraft on orbit, you have to have a license from your country and also from the launching state. And some countries are just like some billionaires that can I get put 10,000 spacecraft on orbit? They say yes. Yeah, and then there's also an international non-binding regulation of that you should not occupy space. Nobody should be doing that. But if you put 10,000 spacecraft on orbit, is that occupation or not? I mean, legislatures should decide whether it is so or not. But right now, it's as Mr. Ahmed said, it's a wild west, and it's great that we have countries like UAE and Finland who are taking the sustainability seriously, and hopefully the countries which don't have as sustainable legislation will follow them later on, because there's also a reputation that we have in mind. The companies, there are lots of I mean, Finland is very there are lots of space-related upstream startups now. We have Aluminum ISI, the world leader in science technology, small spacecraft science technology. Companies' reputation is something that they very much value. If they lose their reputation, it's the same as in science. So if we lose our reputation, we don't have anything anymore. And that's also one point which is of these bottom-up things that might actually become very important in those countries which don't have so advanced legislation as we do.
You talk about besides the space product, something like space mission.
Yes, Finland is very much keen on this, and so space situational awareness basically normally is divided into space weather and near objects, and then tracking of the three particles. And Finland is very much doing all these three. And if we think about these three, the strongest by far is space weather research. Finland has very long tradition in space weather research, experiment neosphere, solar eruptions, so on. And that has to do with the fact that we are so north. So people have been looking at the aurora for a long time and been wondering what's going on, and that's why we have a strong space weather research agenda.
Let's open the floor for the audience. Please let me ask question to our panelists. Please feel free. Yes, please, Ahmed.
Earlier this year, in March, there was a launch of the end of life service to demonstrate how we can fix this. So it has a magnetic docking software, it has also a longitudinal state pattern, which has clock line. So current ones what we are fine. But my question is, will it be able to take off the current or will it be just for the future satellite which has it?
I would say that the first thing to do here is to dock, because nobody has docked before, actually. I mean, that it's a fact. There's no such thing as docking event that has, I mean, even the docking, if they are able to do the docking, that's already a revolution of some sort. Yes, and then docking to the debris particle is probably much more difficult than docking to a spacecraft. And then, by the way, there's no regulation on docking to a spacecraft. Anyway, so I'm like very keenly looking at this mission, and if they succeed, that's great. And that's a very, very ambitious and difficult program that they have. But it's great that they are trying to do that. If they succeed, it's a great revolution.
I could just add to this in the future, the material, may hopefully after the engine, whatever, maybe the material disintegrate naturally, like improving the space environment. So that way, we don't need to be orbiting or enrolling or hijacking, if you like, or dropping. If the material itself, I think that is the way forward.
I didn't even what to say, so I think this is a very interesting thing that buying or degradable absolutely is a lot lately. one thing that hasn't been mentioned yet in taking the grid out is actually space weather. Because when you have these very large space weather events, the atmosphere is heated, it's lifted up. There are actually other countries than China have also been doing this anti-satellite test. There was one anti-satellite test from the US in 1988. They made an anti-satellite test to their own spacecraft, which was on 500-kilometer orbit. Then a miracle happened. A very great space weather storm in 1989. This was the storm which stripped the power network in Canada, a very famous storm. Atmosphere was lifted up, and the debris from the anti-satellite test was actually burned by this space weather. So actually, yeah, I mean, if we have the great storm, it also can help. Yeah. Yeah. Yes, that's correct. So, I mean, one of the things that I haven't mentioned here, which I'm also doing, is I'm researching these major storms, these Carrington level storms, which are like could be of could disrupt power networks in many places. Also, might be also in here, and even though we are in Palmorth latitudes, because the latitude here is around the same as the Carrington, where they saw aurora during the Carrington storm. So.
Another question, and this for the three. Each is true. Each supply, each small supply, has its own small rockets. So could we put this supply in a proper orbit or a hyperbolic orbit to get it from there in deep space? This could be for the future, even when we design a new satellite to load it with shell more rockets in order to put it in the future in the hyperbolic orbit.
Yeah, so having a sort of a gas station, like Newport, for instance, if you're going to Mars or somewhere, you can kind of for a while rest on this nice station, and then you go forward. I think there are some papers about that have been written about ideas.
It's very high temperature, which is it's already costly.
This could be easy for the not empty of the lower orbits, but for the higher orbits it would be easy.
All of the satellites, you have one day, once the system is over temperature, they have to be the higher. As Mama said, we have to have a system to 40,000. I don't know. Most of the kids are, as a 90%, they don't have to. So let us do the job. If you go into them, maybe it's more it's meanwhile, Chinese one.
Yeah,
but it is any more questions from the audience, please?
Hello, yes, this is Yusuf from the Kids Center. So my question would be, where do we start? Is the key to solving the sustainability issue relying on manufacturers, where they have to design materials? Is it from the space legislators, or is it from private entities? So for example, the race to space now is not being led, at least this is my opinion, is not being led by government institutions. Some of the launches, if not most of them, are being performed by private institutions like SpaceX. So could the key solution be from the manufacturers? They decide sustainable materials, would it be from government legislators that your satellite should have a specific mission, a specific lifetime, or from private entities?
This is a great question. I mean, look at the climate change negotiations right now. So, I mean, if they are trying to get a binding regulation from governmental discussions for what it takes, you guys are having that March already before they reach a conclusion. So I would say it would be very important for the universities and technology developers to actually find solutions that could be taken solution to this problem, I think it's speed up the negotiations very, very much, because otherwise it's going to be, I mean, China doesn't give any, I mean, the big players don't probably want to give their kind of gain position away, so why would they do it? So there's no incentive for the big players to kind of say that, okay, well, we've been unsustainable now, and we'll start to be sustainable now. I mean, it doesn't happen like that. So I would say that universities like yours are very important for the future, because you guys are the ones who are developing new technologies and giving new ideas. And same here, of course, in Minna. So I actually do believe more in the bottom up than in the point recording it. You are putting in the YouTube. So I would say that the best place for that would be the UN Compost Committee for Outer Space, which is covered by United Nations. Yeah.
But the problem is it's really that anything else, anybody knows, if there is no regulation, whether we're going to do it. Look at the sector, whether the water sector, manufacturing sector, construction sector, whatever, there's no regulation, everyone knows for their and the regulation is fine, system is fine. So I should simplify the bottom up, we send them space, okay? Plain, whatever technology is all information, you could control or manufacture, and then legislation, because as you said, whoever is going to be the license, before the license, 1, 2, 3, 4, 5, they have to meet this regulation, and that can be adjusted and adopted. Why nobody wants to come together in this particular time, because they see the space exploration kind of value, knowledge is power for an institution, and the fund as well. Why institutions getting a great deal of fund, okay, when another institution is not, and they want to share it more. So, and I think we got duties here as scientists, as you said, academic, community, society, whatever, is what we're going to send up there. And I think it's the material work, the manufacturing work. And this is the ICT in the direction.
And what is really the key here, and the core issue, not actually, it is the education. And because this is a huge problem which needs to be solved, same as climate change. There are very many different, very huge problems that our world is now facing. The only way to solve those is by education. And I would say also diverse education, very importantly, because those problems are so huge, we are losing talent if we don't promote all nations, all people, all types of viewpoints to solve those problems. So, I think it's very, very important for having a diverse educational system. And I mean, I was very impressed at what you said about your publication numbers to go from 200 to 1,500 in less than 10 years. It's a massive achievement. Congratulations on that. So for really having a vision for education. It's very, very important.
I think she agreed that in a similar way, the professor already mentioned the financial and you mentioned the regulatory framework. So if we make it also economically sustainable by regulating and putting in place the framework in a similar way as for getting carbon neutral, there are also economic opportunities and pushers and others, so that there will be new innovations and people will start to look into the problem as a possibility to build something So would this be a kind of seeing the framework as a enabler to make it sustainable also economically, so that if something is not demanded, but at least make so that that the companies will realize, oh, there's a possibility here, then there will be a change.
Certainly, yes. I mean, if you look at the graph that Minna put here, the Cold War era, the 50s to the 70s, that windows, the number of the flights on 600, 360 or so. And then suddenly you have 900 plus, where the private sector, they realize there is something in it for them. So from the economical side, from the legal side, from the development side, seeing the big picture. Initially, they said, leave the academic, leave NASA, leave all the exploration institution to do the homework. It's just like on air here, we're doing a research, proof of concept, pilot. To look at it, is it going to work? I'm going to manufacture something called my mobile phone. What is required? Required this processor, computer, for example, what sensors, right? There's a proof of concept, pilot, industrial study, and then the application. Now we're talking about the space. So the industry see that there is a massive opportunity here. Some countries see that what we've done a lot of things here because the economical benefit. What helping is the new generation. The new generation, you're not going to do anything just to say of a proof of concept. They want application, they want a problem solver, and what's at the end of it? We see it with our students. I'm sure I agree with you. Teach them equation in physics, and the student just switch off with a second. But the minute you tell them this equation is important because you're going to do this, the student working on because they see the benefit of such formulas, such element. So I see the same thing here, seeing the big picture. One ends in explorations for the moon, for Mars. What's in it? Is it really just a pure science? Is it bigger than that? Is it from economy, legal, from this is what all the countries in mentioned talking about SDG, the Sustainable Development, agenda. All that encapsulated is exactly what we're looking for. There is it. Otherwise, why are you spending billion and billion and billion for what? So the world is changing. Benefit what has already been done, but do something else. Can we benefit from the weather, for example? Can we control? We have this AI, we have deep learning, can you control this? Something else, i.e. for mother, can you manipulate for mother nature is dictating everything? Can you manipulate something? So it's a lot of that. That is what the world is.
How could you relate this economical sustainability to the sustainable use of space? This is, I think, the key point. If we go back to the day when we polluted everything to make money, how can we then make it so that the companies see the problem well ahead and they feel that they have an incentive to work so that we don't end up with that curve later?
Yeah, well, if you think about with the Chinese anti-satellite, or let's say the collision of the two spacecraft, of the Russian spacecraft and the Iridium 33 would have been between one company and then one very vital weather satellite or something. That company would not then now have a very bad reputation. Everybody would say here that, look at this collision here, and this company made this collision. So what this reputation is like is one key. But of course, trust is something, but really to control it is another thing. So I would like, if I may have a few time, I don't know how long.
That's what I have.
Yeah, but just comment on this. You are absolutely right on this benefit, Mr. Ahmed, that students nowadays very much think about what is it for me? How can I utilize the equations and so on? That's absolutely right. The other thing is that we also have to think about science as like having a value of its own. Because, for instance, like think about electricity, and Henry Faraday, who developed the equation which enabled the production of electricity. So Faraday's equation is the basis of electric production, generators, and so on. Faraday didn't find the equation because there was some government committee who said that Henry go and find us an equation so that we can make money. But Faraday didn't patent this equation. He would have patented it. Faraday family now would be the richest of everybody. Everybody would be like they would own the world, basically, because everybody is using electricity. But Faraday, what he actually wanted was he was thinking that if I can find this equation, maybe I can see God behind the world. So that was his driver. So and now we have electricity. To say, I have so many stories about this. One similar is Palmorth in Italy. One of the early researchers behind electricity. He was like putting like dead clocks on the table and like poking them with the electrical. Yeah, and the clocks were jumping down, and Luigi was like, yeah, I know I have this animal electricity, and like then it was like, I mean, nowadays, if somebody would be poking clocks on the table, government would come and say that stop, that's not ridiculous thing and do something useful.
That's right. So I think that going back to basics is one subject attracting whatever you find the new generation interested in science and physics and engineering and medicine. But one subject is the space. Anyone, regardless of their background, whether theoretician, whether practical, whatever, always mesmerized, because human nature like to see must be more.
Yes.
That is the attraction for it. So you can see this is an opportunity for all these people when research companies are interested to do research in any kind of research, and especially in space, cost money for exploration. Since the companies are interested, and I think it's a great action now for the academic to capitalize on hopefully bringing the new generation into that. By the point, everything has to have a value for money, not just to say for exploration. What's in it? What's the value for the money? Because that is cost. Plus, we're coming back into the sustainability, we're going back into the green agenda, and so on and so forth. And this system, if we are in that mindset, I think we're in the right direction. But as you mentioned, how long since we born, I've been hearing about climate change. Are we having a different drive? Are we having a different champion for that? The world, the human nature, the mother nature showing us every day what can do, what the world can. I think with the space exactly.
Yes, I just want to highlight and discuss your point. I think we're looking at the economics from the production side. I think your meaning is the economics of recycling. I think we're failing in space like we're failing on Earth right now, because the science and engineering and economics of recycling is not there. We still we don't see the economic benefits in recycling whatever rubbish and trash we in our own lives. Our seas and oceans that polluted with plastic, microplastics. Our atmosphere was polluted with lead and all kinds of heavy metals from emissions from cars and so on. But we are not really actively and serious about finding solutions for that because we don't see the economic benefit of that. Yeah. We're slowly moving there. But I think once we see, as you said, the economic benefit, but not in sending satellites, because clearly we see that, and that's why you see the big jump in the private sector going to space, because we see the benefits, economic benefits of going to space. Now, is there economic benefits in recycling whatever there in space? Because these companies, if they realize that if it would just bring profit like $1 billion to send satellite up to space, and then maybe we can get back like 50 million if we bring it back to Earth, or if we recycle it, or if we reuse it or something, then they will do that. But so far, I think the economics tell them that this satellite has a lifetime, it will generate such money from such service, and then forget about it. And like we do now, I mean, we generate cola bottles and plastic bottles to drink water, because that makes money, but we don't think of how to make money once it gets to this stage. We throw it away. So I think, yeah, so I think that's your point, yes? It's how to come up with economical ideas for recycling.
Yeah.
And science as well.
Except in Finland, we do recycle plastic bottles. Anyway, so the problem what you are talking about in economic terms is called the problem of the common pool of resources. And like it has been noticed like hundreds of years already, that when somebody doesn't really own, I mean, if, for instance, the water in the New York City hundreds of years ago, everybody owned nobody owned the water pool, and everybody used it. And since everybody used the same pool, nobody was like caring about the water pool, so it very quickly became very polluted, and nobody could drink it anymore. And now it's like covered with. This happens everywhere. Mexico City, the same thing. If you look at the Aztec old pictures of Mexico City, it had like rivers. You go to Mexico City now, it's totally concrete. They have used, because exactly of the same resource, nobody owns the resource. And now in this paper, which I'm thank you for reading it, what was sustainable use of space, we had an economic professor in economy who was thinking about this space debris problem from the perspective of the common pool of resources. And he says that, for instance, I mean, River Rhine in Europe, the same thing, it took ages for them to agree how to utilize the water so that it stays clean, because it's so that everybody on River Rhine is very long, and it's been used several times before it goes to the ocean. So people drink it over and over again. So it has to be pure. Otherwise, if the ones who are up in the upriver part, if they go, everybody else will die on the shore. So common pool of resources, it's applied to space. It means basically two things. One is agreeing about something which we call sustainable satellite footprint. So how many spacecraft can you put on one orbit? And that is a function of the spacecraft manufacturer. If it's a maneuverable spacecraft, you can maneuver, it's a better thing than a zombie, because then you can take another orbit if there's a danger coming and so on. It's also a function of the size of the spacecraft. If it's a collision between large spacecraft or small spacecraft, then it's a bigger problem. It's a large way. So anyway, footprint is one thing, and then the other thing that this economic professor was thinking about is capacity, because in economics they have this understanding of capacity, and they have theories for, like they call queuing theories, that when can we launch the next satellite is when the space that it has allocated has been emptied. And this is called capacity theory. And however, now if you go to United Nations and suggest that let's agree on this capacity, how can we have an orbit capacity and common rule, when are we able to launch spacecraft? What happens, like, does China, for instance, take it up like, yes, of course, let's do this capacity.
Yeah,
So
this is into the light pollution that these lights actually that do in the space. I remember the first time when SpaceX launched 60 satellites at the same time in one launch, and we have been able to see by naked eye just a whole trail of satellite. These actually would remove the atmosphere for the astronomers. When we observe stars or galaxies with an open shutter for 1 hour, you will see too many objects, too many tracks.
Just for the last question, do you think we can get this agency because if you think the world just south, most of the southern countries are poor, they can never do have space program. So we experience the best can be good. So especially with the main player are not so selfish.
Yeah. I don't know, this is a very difficult question. Like, general answer to this is that, in my opinion, we are now at the brink of the next era. Similar as Colombo found America while exploration, that was the brink of the new age. Now we are at the brink of the new space age. And it is now that the countries decide whether they are in it or out of it. And then there's going to be a divide in the future. Those who are benefiting the new technologies and those who are not benefiting. Exactly right, that if they are not investing into this technology development right now, they will be left out because the progress of the ones which are like here in UAE, I mean, the progress that you've done in a matter of 10 years or so, 15 years is huge. So it's like the ones who are now doing it are the ones who are benefiting from in the end. And then there's this divide country. I mean, now the Finnish embassy will host another professional in space law, Jenny Tapio, who is coming to this IAC conference next month. And she's the vice chair of the UN Prof, or will be. And I mean, hopefully there will be some discussion on this topic again, because again, he's much more knowledgeable about this than I am. So he knows everything about UN Prof.
Not to do what was rather NSC space story, it's Sharjah, my friends for 4 years.
And there are also by laws and regulations done by UAE. Remember, Syria made comments in these by laws. It's good to have a look.
Okay, thank you very much. Thank you, Professor Minna. Thank you, Professor Ahmed. Thank you, Professor Mashkoor. Thank you, Professor Ata, and everyone who participated. So please, we have a special lunch for our guests. Please participate with us. It's free.